lights tutorial. In part 1, I showed you guys how to design the circuit, and I showed you guys how to select the components. And you can watch that video here if you haven't already seen it. In part 2, I'm going to show you guys the physical board design as well as how to program the microcontroller. So let's get started. Okay, so we're back using Eagle software, and this schematic should look familiar to you guys if you watched my first video in this tutorial series. And this, of course, is the electrical schematic. And again, I'm using CADsoft Eagle software, and we're going to be switching over to the physical board design in a moment. And the physical board design is actually the easy part. The electrical schematic was a little more tedious, and the component selection involves some math. But the physical board design is a lot easier. I'm going to show you guys how to do that in a moment. But the first thing I would suggest before switching over to any board design is you guys have to find yourself a manufacturer to manufacture your PCB boards. And I'm going to show you why this is important in a moment. So I prefer to use Seed Studio. So I've pulled up their website here, and their service is called Fusion PCB Service. And the reason I like this service over any others that I found online is that they make the boards in a matter of a few days. Yes, they have to be shipped from China, so it will take a few weeks to get to your door, but the service is excellent. I had little to no failures of any board so far, so the quality is there, and the whole process is just super easy. So the reason you do this first, of course, is because you have to select your board size, and that's going to determine your price. And you can kind of, once you get used to the board design, you can take a pretty good guess at what size of a board you need to fit all of your components. This is a very small project, so a 5 centimeter by 5 centimeter board is perfect. And each manufacturer may have different options, so this is why you do this first. I use Seed Studio, so we're going to be making a board that has dimensions of 5 centimeters by 5 centimeters. And you can go as large as 30 centimeters by 30 centimeters, which is pretty much a square foot, and that's a pretty big board. So this service is great. It's also cheap, $10 for 10 boards, and those are 2-layer boards, and that's all you should need for this project. Standard green PCB color, standard surface finish, pretty much all the standard options will do for this particular project. So let's now switch back to the schematic right here, and I'm going to show you guys now how you get into the board design. So if you're in your schematic in Eagle and you head up onto the file option up in the top left corner, you can see switch to board. And now I've already created this board, so I don't need to do that. This is the board, and it's just pretty much in another window. And you have these two in Eagle. You should have these two things open, the schematic and the board, at the same time every time. Do not open one without opening the other. It will break the link between the two, and you'll get some sort of weird error in Eagle. And of course, you don't want to sever the link between the two because they're connected. And I'm going to show you guys that also in a moment. So actually, I'm going to actually close this project. And I'm going to open a tutorial project that I started. And it's just a super simple schematic here. I'm going to be using this to teach you guys how to do the physical board design, just because the actual project with the programmable LED lights, there's so many components and it would take too long to show you guys. So with our example circuit, we can now switch over to the physical board. So head on up to File, hit Switch to Board. You'll be prompted to create the board from the schematic. Of course, we say yes. Your new window pops up, maximize your window, and you have your physical board design now. One thing that I noticed that's missing on mine is the grid. So you can hit View Grid. I want to turn the display on. My manufacturer works in centimeters, which is metric. So I want my grid to be in millimeters, which is also metric. So switch those both over. The style will be lines instead of dots. And I can hit OK. And the faint gray lines that you see in the background will be the grid lines that you'll be working with. If you cannot see them, you may have to maximize your view in YouTube, because these very, very thin lines will get distorted if you're not watching this in HD. So now, one other thing I want to make you guys aware of is in the top left-hand corner, you'll see that I've highlighted here this is the coordinate system, and these numbers represent where you are on your board. So I'll clear that. And as I move my cursor around, you can see my coordinates are also changing. The origin can be found on the bottom left of your board. So down here, you'll see a little crosshairs at the bottom left-hand side of your board, and that is your origin. So that is your 0, 0, 0x, 0y. And my board dimensions right now are not 5 centimeters by 5 centimeters. So I can grab the move tool, click and drag on the walls of my board, if you want to call them that. And using the coordinate system in the top left, I can get it to about 50 millimeters, which is 5 centimeters in the X, and 50 millimeters in the Y. And now I'll zoom in on this. Now you can see our 5 centimeter by 5 centimeter board, and on the left hand side you will see all of the components that we added in the schematic. The symbols will look different because these are the footprints, the physical footprints of the components that you selected in the schematic. So in our example, we have a battery, which using the move tool, I can click on and drag. So I'm going to drag that onto the board. The switch, also going to drag that onto the board. The resistor, and 3 LEDs. And you'll notice that there are these yellow lines that are connecting each of the components. These lines are called your air lines, and these lines represent the connections between the pins or pads if you're using SMD components. And these will eventually turn into your PCB traces. So what you want to do is you want to organize your components in a logical manner that makes your board look clean, neat, and organized, and minimizes how many of these air lines are crossing one another. Because of course, like I said, these are going to turn into your PCB traces. So the more crossing that you have on these traces, the more complex your board is going to be. You're going to have to use more vias to switch to different layers, etc., etc. So make it as clean as possible. This is obviously a very simple circuit, so it was extremely easy, but there still are some crossing of lines, or they're on diagonals or whatever else. And we can kind of fix that ourselves very quickly by using the rotate command. And we can rotate components and sort of clean up how everything looks. So I'll just go ahead and rotate these quickly. And that should be fine. I may space them out just so you can see the names. And that's very, very easy, very, very simple. Now, the other thing you'll notice in this board is that I've connected the negative side of the LED directly to the negative pin of the battery. Now, when you have a board with a lot of ground connections, you probably are going to want to use a ground plane. And I'm going to show you guys how to create that ground plane, and we're going to actually change up the schematic, which is also going to show you how the board and schematic are connected in a sense. So I'm going to switch on over to back to the schematic. We're going to create a ground plane and a ground component. And I'm going to show you how that changes the board. So back in the schematic, we have, like I had mentioned earlier, we have a direct connection from the negative side of the LED to the negative side of the battery. So I'm going to delete that. We'll just click this, delete, 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 delete. We're going to add a component. So it's going to bring up the library. I'm going to find ground. So we can say ground supply symbol. There's 2 of them available. Just pick one. I'm going to add that here, and I'm going to add one here. And then, of course, we can connect these. That's good. Okay, so now that we have both of our ground symbols, we can switch back to the board and see if there's been any change. So now that we're back at our board, you can see that the air line connecting the last LED to the battery is still there, indicating that the connection has not been broken between the two negative terminals, which is great. What we're going to do now, though, is we are going to create a ground plane. And so rather than having a single trace that goes from the negative pin of the LED to the negative side of the battery, we are going to have an entire pretty much layer of the board that is dedicated to ground. So to do this, just head on over to the symbol that says polygon. So I'm going to click that. Once I've clicked that, notice in the top left hand corner you'll see a menu that will allow you to select which layer you want to draw this on. So I'm going to go ahead and select the bottom layer. Our board will have two layers, as I showed you guys earlier when we talked about selecting your manufacturer. So of course, two layers means a top layer and a bottom layer. Now I can go to the outer edges of my board, draw this blue polygon around the entire board. Once the shape has been closed, our shape is clearly just a square, it will turn into a dotted blue line. From here, you can select the option on the left-hand side. It's called Name. Click that. We will click on our polygon, and we can change the name of our polygon to Ground. And what this will do, you'll see in a moment, is this will now connect, well, this will technically represent the ground symbols in our schematic. And from there, now this is the great part that I love about Eagle. If I hit Rat's Nest, you'll notice that it fills in this entire plane. And what you see missing now is the airline, that yellow airline that connects the negative pin of the last LED to the negative pin of the battery. And if you look very closely, I'll zoom in here so you can see it. Now what you'll see is that this ground plane is actually connected to the negative battery terminal. And you can see how it's connected in blue here. So essentially what you've done is you've eliminated one of your traces. And like I said, you've created a ground plane where all of these ground connections will be connected. And the same thing will happen to the last negative terminal of your last LED. And it's also connected to ground, and that's perfect. That's exactly what we wanted. And now finally, another great part of Eagle is you can use this AutoRoute feature. So on the left-hand side, you hit AutoRouter. A bunch of your options will come up. So in general, you select your routing grid. You can select your via shape. We'll have a round via shape. We can change that to octagon, whatever else. If you guys aren't familiar with what a via is, it is basically like a connection between two layers, and they show up as circles essentially. They look like terminals for where you connect your through-hole components, but it actually bridges the two layers. So if you had to bridge a component between the top layer and the bottom layer, or sorry, bridge a trace, you would use a via. And that's pretty much it. I can just hit OK. You'll notice that it went through a few iterations of trying to solve this board, and it has created red trace lines for the connections on our board. And there still are some airlines here, which is a little bit curious to me because this is actually usually very, very good at pretty much completing the process 100% for you. If, however, it does not complete the process for you, then you're going to have to manually route these components yourself. So if you want to do that, or if you need to do that, you can just head on over, hit wire, and make sure you're on the top layer. So our top layer is red.
And I'm going to manually wire these connections. So from there to there. And then from here to here. Once I do that, I can now hit again rat's nest, and you'll notice it's very difficult to see, but the yellow airlines have disappeared, indicating that the connections have been made. And that's pretty much how you go through this process. But essentially, this is the general idea of what you're going to have to do. And it's, of course, going to take you a lot more time for a board such as our programmable LED lights board, because there's a lot more components. Okay guys, so I've opened the programmable LED lights project again, and I'm in the board design environment. As you can see, this is a little more complicated than that simple circuit that I created earlier, just for to use as an example. This is something that just takes a little bit of time to do. It's again not difficult. As long as you follow those steps, you can create something like this, no problem. And I fit all of this onto a 5 centimeter by 5 centimeter board. And as you can see, most of the traces are blue. And what that means is that most of the PCB traces are on one layer. So I almost only needed to use a 1-layer board. But of course, when I hit the rat's nest button, you can see that the red is my ground plane. And you can faintly see the blue lines in the background. They're the bottom plane, or the bottom layer. But the red plane will be where all of the ground connections are made. So I really did need 2 layers for this board because there are a ton of ground connections. But for the traces, I organized the board in a way such that all of the traces, for the most part, are on 1 layer. And now we can go ahead and create our Gerber files. So in the top left-hand corner, there's a little button beside the print button, and it says CAM processor. So I'm going to go ahead and click that. And we get a prompt here where we have to load some options to tell Eagle how to produce our board. Now, if you go to File, Open, and we're going to open a job, it's going to navigate to the CAM folder. Okay, so in this folder, you'll see a bunch of CAM files. And these are all just directions for Eagle to produce boards in a certain way for certain manufacturers. The one that I'm going to be selecting doesn't come with the Eagle software, so I'm going to put a link in the description to a GitHub link where you can find this file, and it's called sfe-gerb274x-jeb.cam. I think this started off with SparkFun. There's another guy on YouTube that does some great Eagle tutorials. I found this, and this is on his GitHub, so I'm going to link to that. And this works great with Seed Studio. So I'm just going to select this file. And now you'll see a bunch of new tabs open up. So top copper, bottom, top silk screen, top solder mask, bottom, so on and so forth. And you don't have to adjust anything because it's already been done for you, which is great. We can just hit process job, and that's it. Job's done. We can close this window. All we have to do now is on our computer, navigate to the folder where we saved our project, which is right here for me. And I have a whole bunch of new files in there, and there's a bunch of them named. The ones that we're going to be interested in, there's like .gbl, .gbo, .gbp, and these are all of your Gerber files. And there's also a text document which we're going to be interested in. Now, if you need to know exactly which ones you need for manufacturing, you can ask your manufacturer, or if you're using Seed Studio, go to the frequently asked questions area on the Seed Studio website for the Fusion PCB service. And here you can find the Gerber file requirements, and it will list every one you'll need. So the top layer is the GTL file, solder mask is GTS, top cell screen GTO, so on and so forth. So you'll see that there are 7 of the Gerber files, and then there's the text file which shows them where to drill. And so you have 8 files that you're going to need. You can pretty much, like I said, go back into the folder where everything is. You can select them all, GBL, GBO, GBS, GML, etc. text file, and you can pretty much just zip them into one file. create your one zip file, name it after your project. Once that's done, it's just a matter of going back to the Fusion PCB service. You can drag and drop your zip file or just click to find it. Once you have that done here, you can even view it on their website. There's a Gerber viewer file just to ensure that you're ordering what it is that you want and everything turned out the way you want it to look, and then go through the whole online ordering process, which again is really easy. Pay with your credit card or PayPal or whatever. And hopefully in 3 or so weeks you get your boards in the mail, which is obviously really exciting. Unpack them, they should turn out the exact way that you wanted, and then you can solder all of your components to the board. And it probably would have been a good idea at the same time as buying the boards to buy your components, because those are probably going to come from China too. And you'll have everything at the same time. You can solder it all to the board, and then I'm going to teach you now how to program that board. Okay, so the boards came in the mail. I already soldered all the components to the board, and now it's time to program this thing. And I already have some wires hooked up to the board for another project that I'm working on that I'll cover in another video. On the bottom side, I've soldered the adjustable voltage regulator to this board, but programming the PIC AXE microcontroller, which is right here, is very simple to do, and let's go ahead and do that. So in order to do this, you need to have a few different things. So one of the things you might need to program a microcontroller is a little board with a socket where you can attach your microcontroller. And of course, you'll need some sort of input, and that would be a USB to serial cable. So one side is USB, and the other side is just what looks like a simple headphone jack. And that, of course, will connect to the headphone jack receptacle on this programming board. But you don't really have to invest in one of these things. This is typically only if you're plugging a controller in and out of a device over and over and over and programming it for different functions. For us, we're going to program it once, and we're pretty much just going to drop it in our car or wherever else we're using it, and we're going to leave it. So we're not going to be using this, but we do need to get the information, the program off of our computer. So USB to serial, and I just made a very simple cable that will connect to the board. So if you remember in the board design, I put 3 header pins on the board. So one of them will be serial in, serial out, and then a ground. And I just took an old ribbon cable and I pretty much just cut up the other side, and I put my own headphone jack just to connect to 3 of the wires on this side. And so obviously make sure you have them in the right place, and you can just slide your connection from the ribbon cable onto your 3 header pins, and that gives you a programming circuit. And so on this end here, the other end of the ribbon cable, I can go ahead and attach that. Just a little quick solder job on the other side, and I pretty much have now a USB connection. If I can find the USB end, it's a bit of a tangled mess, but the USB connection will connect to our computer. And so now I have communication between the computer to the board, where I've already soldered the microcontroller. And like I mentioned in the first video, in the schematic, there's a few resistors that are responsible for handling the logic to program this controller, and it's all built into the board, so you don't even have to buy that other board. It's so easy to do. And even in the PIC AXE documentation, which I showed you again in the first video, it shows you the circuit, and like I said, we've built it into this board, so you can program this as many times as you'd like, and you never have to remove your PIC AXE. So now let's switch back to our computer. I'm going to show you the software that you need to program this thing, and I'm going to show you how to program it. So just simply plug the other end of this into the USB on your computer, and actually the only other thing that you'll have to do is provide power to the board. So in this case, my adjustable voltage regulator on the bottom is set to output I believe 10.5 volts. So it'll output the 10.5 volts, and then our 5-volt regulator, again, which I showed you in the first video, it will step down the voltage to 5 volts, and that will provide PIC AXE microcontroller with the power it needs while you program it. So those are the two requirements. Make yourself a little cable, super easy to do, and provide the board with 12 volts, and your voltage regulator will take care of the rest and power the PIC AXE. Okay, so now our board is physically connected to our computer, and with that connection we can start writing our code and uploading it to the PIC AXE microcontroller. I'm using the PIC AXE programming editor to write my code, and this is software that is provided by Revolution Education. I will provide a link to that in the description below. These are the people who make the PIC AXE controller, so you know the software is going to work great with the microcontroller. And the first thing you want to do when you open up your programming environment is you want to hit Options, and you want to select the PIC AXE model that you are using on your board. And in my case, I'm using the 18M2 Plus. So there it is, 18M2. And the next thing I want to do is I want to hit the serial port tab, and I want to select whatever COM port I'm using for my USB to serial device. So for me, it'll be COM1. I can hit apply, okay, and we can get on to programming. So the programming is done in the basic programming language. I don't personally know a whole lot about the basic programming language, but it's, as it sounds, it's quite basic, and you only need a few commands to start flashing your lights on and off, and that's all we pretty much need to learn. So I'm just going to go through a few of the very simple commands to do that. And at the top of our code, we're going to be declaring a variable, as we do in a lot of programming languages. This one is the step delay, I've called it, variable, which is measured in milliseconds. So my delay will be 150 milliseconds. And the following code in the main body of your code will be, first of all, to set all of your output pins as output. And so each bit of 1, 1, 1, all these bits here are just basically saying all of your B pins are outputs, and then all of pins B will equal to 0. So make sure they're all starting in the off position. So now with all of our lights off, we can just go ahead and say high, so that's turning it on. So B.0, which is our first output, turn it on. Then we pause for our delay, which is 150 milliseconds. And we continue going on, off, etc., with some delays stuck in between. And this code here, when I get to the bottom, we'll get to the point where you've now sequenced all the lights on and off in a chasing LED pattern. And at the very end, I turn them all on because I'm using this project for daytime running lights. So every time I turn my car on, I get a cool sequencing effect, and it will do like an LED chasing sequence. And then after 3 seconds of this, it'll turn them all on, and I have LED daytime running lights that remain on while I drive. And every time I turn the car off, obviously the LEDs turn off. And when I turn the car back on, it goes through this power-up sequence, as I like to call it. And it just gives a cool effect every time I turn my car on, and people who are standing around will notice your lights flashing. And it's just a cool effect that I like to have done to a lot of my cars. So that's what I'm using this for. Of course, you can use this for turn signals. You can use this for whatever other projects you like. But you can program the lights with infinite flexibility. And you can even use the PWM pin on the microcontroller. Some of the PIC AXE models have PWM outputs, and you can figure out in the basic programming language how to use that to your advantage to maybe fade lights on and off, or whatever other effects that you want to achieve. So that's pretty much it. Once you've written your program, now it's time to just simply upload it to your PIC AXE. So remember, the two requirements is that obviously your serial connection is made through USB to your computer, and your PIC AXE at this point should have 5 volts power. So in our project, the 5 volts power is supplied through the adjustable voltage regulator and then through the 5 volt voltage regulator. So if everything's on, which right now mine actually isn't connected, so I'm going to get an error here. But if you've done it right, you will not get an error. You just head up to the top, hit PIC AXE, hit program, and it will attempt to connect to your hardware. There's a progress bar here. Of course, like I said, mine isn't connected, so I get an error. But if yours is connected and powered properly, the progress bar will proceed to 100%, and it will confirm that your pickaxe has been programmed. And as soon as that pickaxe is programmed, it will execute the code immediately. And so if you have LEDs hooked up, you'll see them start to flash, and you can test your code and modify it and then re-upload and retry it over and over and over until you get the effect that you want. And like I said, in my case, it runs through the code once, and I'm happy at the end with my code saying all of the LEDs remain on. But of course, if you're using this for a different sort of project and you want it to loop, you just have to look up the loop commands for the basic programming language, and you can have your pickaxe run your code over and over and over and over and over until you remove power from the pickaxe, and then of course it will just turn off.
All right, so with the board programmed, it's time to test out the code and make sure it's what we were looking for. I have my LEDs set up in a 3D printed pod, which is going to be used for my new daytime running light project I have for another vehicle. I'll show you guys that in another video. But in the meantime, let's apply power. You'll see the lights start to sequence. They'll go through the code, and then they'll remain on. And those will be my daytime running lights on another vehicle of mine. So it just adds a cool custom effect to your vehicle, and it's something that I do to a few of my cars just to add my own personal touch. So I hope that helps you guys with this project. Of course, you can use the schematic and circuit for your own projects. I encourage you guys to ask questions in the comment section below. I'll answer every one of them to the best of my ability. Hope that helps. Enjoy your new programmable sequencing LED lights.